Okay, hi everyone, welcome back to this video series. Introduction to Firewalls, Chapter 12, Designing Demilitarized Zones with Multiple Firewalls. Some organizations are apprehensive about implementing a single firewall between their private network and the internet. Although you can add more interfaces to the firewall, a single firewall solution has one big drawback. Only one point of failure exists between a hacker on the internet and your private network resources. This chapter examines some demilitarized zone DMZ designs that use two or more firewalls to protect the private network from the internet, thus allowing secure access to internet accessible resources while still providing maximum security to the private network. When two firewalls are better than one, some organizations' security policies dictate that a single firewall protecting the private network from the internet is unacceptable. In Chapter 11, we stated that a single firewall can be used to deploy a DMZ that directs internet-based traffic to a protected area of the network. However, some security personnel are uncomfortable with this design because the firewall becomes a single point of protection. If an attacker were to compromise the firewall, he or she would not only gain access to the DMZ, but would also have access to the private network. Therefore, security administrators generally prefer DMZ solutions with two firewalls as shown in Figure 12.1. In this scenario, the two firewalls separate the DMZ from both the private network and the internet. Although additional costs are associated with the additional firewall, this configuration is considered more secure because an attacker must breach two firewalls in order to access resources on the private network. Typically, the business factors that result in an organization's deploying two or more firewalls in its DMZ design include clear definition of the DMZ. When two firewalls are used, the DMZ physically resides between the private network and the internet. Increased security by deploying two separate firewalls, an attacker must circumvent or break through two separate firewalls to compromise resources that are located on the private network. Reduced network loads on the two firewalls. In a single firewall DMZ solution, the firewall may have to inspect the same data twice, once going from the internet to the DMZ and again going from the DMZ to the private network. When a double firewall DMZ is used, this inspection load is divided between two firewalls. Deploying two separate firewalls doesn't necessarily solve all your problems instantly. Some of the disadvantages related to deploying a two firewall solution is the best practice of implementing two different manufacturers' firewalls is used that is included increased costs. This one is simple. Two firewalls generally cost more than a single firewall. The cost is even higher if your organization's security policy requires multiple firewall brands. Extra training required. Although the configuration of each manufacturer's firewall is different, administrators must master the nuances of each firewall and be proficient in more than one firewall in order to be effective when deploying security. Multiple firewall rules listings must be maintained. A firewall administrator may have to modify two separate firewall rules listing to define the necessary firewall rules for allowing network traffic to securely pass between the zones. This results in more time spent administering the firewalls. Multiple tools must be used. Typically, each firewall produced has its own custom interface for managing the firewall. These tools require additional ports to be opened at the firewall to allow management of the firewalls by computers not located in the DMZ, which increases the number of entry points into the network. Configuration complexity when more than 2 firewalls are deployed. If you require multiple DMZs to support protocols that can't pass through a network address translation NAT service, the additional configuration to allow traffic to pass securely through the various zones can be quite complex. The complexity involves not only firewall rule configuration, but also DNS and routing table configuration. DMZs with 2 firewalls. When you use a 2 firewall DMZ, the biggest difference with DMZ configuration is that you must configure the 2 separate firewalls in tandem to control what traffic can pass between the private network, DMZ, and the internet. This chapter refers to the firewall between the internet and the DMZ as the external firewall, and the firewall between the DMZ and the private network as the internal firewall. The external firewall is typically configured to allow only specific traffic into the DMZ from the internet. Typically, only protocols that are used in the DMZ are allowed to enter the DMZ. The internal firewall restricts which data is allowed to traverse between the private network and the DMZ. The best way to describe 2 firewall DMZ configurations is by using examples. The following examples describe 2 firewall DMZ configurations: a point-to-point tunneling protocol PPTP server using radius authentication, a layer 2 tunneling protocol L2TP server using radius authentication, a web server that connects to a SQL backend server for storage of data. Deploying a tunnel solution using PPTP. Figure 12.1 shows a common configuration used to provide PPTP access to the private network. In the configuration shown in figure 12.2, the DMZ can use either private network addressing or public network addressing. In this configuration, because the tunnel server is located at the IP address 192.168.223.22 and address in the RFC 1918 defined pools of IP addresses, private network addressing is used in the DMZ. In addition, the DMZ restricts access to the private network so that tunnel servers are allowed to access only the radius server in the private network located at 192.168.222.3. Tunnel clients are assigned an IP address in the 192.168.223.128 to 192.168.223.255 range, 192.168.223.128/25, and are allowed to access resources only on the 192.168.222.0/24 network. As in a 3-pronged firewall configuration, the first step is designing a DMZ with 2 firewalls is to define a static address mapping for the tunnel server located in the DMZ. The firewall is assigned IP address 23.16.16.5. A static address mapping must be defined to allow only PPTP connections to be redirected to the tunnel server located in the DMZ as shown in figure 12.1. Okay, so PPTP static address mapping, external IP address, transport protocol, and internal IP address 23.16.16.5, ID 47, 192.168.223.22. These static address mappings ensure that all data sent to TCP port 1723 on the firewall is redirected to the tunnel server's TCP port 1723, and that all generic routing encapsulation GRE packets are also rerouted to the tunnel server. Table 12.2 shows the firewall rules that must be implemented at the external firewall to ensure that only PPTP traffic is allowed to enter and exit the DMZ. In addition, the PPTP traffic is allowed to connect only to the tunnel server and not to any other servers in the DMZ. So PPTP TCP any 192.168.223.22.1723 allowed. GRE ID 47 any 192.168.223.22 allowed. The firewall rule listings in this chapter assume that stateful inspection is enabled at the firewall to allow return packets to be returned to the original source of the packet. At this point in the configuration, your process changes from the process used for a single firewall solution. The firewall rules used to allow radius authentication and tunnel client access are configured at the internal firewall because the traffic originates in the DMZ, not on the internet. Table 12.3 shows the firewall rules that must be configured at the internal firewall based on the sample configuration. So table 12.3, internal PPTP firewall rules. Radius authentication UDP 192.168.223.22 any 192.168.222.3 1812 allow. Radius accounting UDP 192.168.223.22 any 192.168.222.3 1813 allow. Internal access any 192.168.223.128/25 any 192.168.224.0/24 any allow. So I'm going to leave it here this evening for this video. If you like listening, please consider like, sharing and subscribing. Thank you.